Hey everyone, and welcome to Research Rumble. This is the game show that's going to get you prepped, primed, and totally ready to crush your phonology midterm. I'm your host, and I am so ready to get started.
That's right. We are turning your study session into a full-on showdown. So you can forget about those mind-numbing flashcards. Today, we're putting your knowledge to the test, game show style, so you can walk into that exam feeling totally confident. So where's all this info coming from? Well, today's questions are pulled straight from your textbook. That's Bernthal, Bengtson, and Flipson's Articulation and Phonological Disorders. We're hitting Chapter 4, which is all about theoretical considerations, and Chapter 7 on diagnosis. We're going to cover the big theories and see how they actually apply in the real world. So get ready.
The questions are locked and loaded, the answers are waiting, and our clock is ticking. Are you ready to prove your phonology champion? Let's do this. All right, welcome to our very first round, Feature Frenzy. We're kicking things off with the absolute fundamentals, the tiny little building blocks that make all of speech possible. First question is coming your way right now. Okay, let's get warmed up with a classic true or false. You've got 5 seconds on the clock. Just think about what really makes a P sound different from a B sound. Time's up. So, what do you think? And the answer is true. Absolutely. That one single difference, that one little distinctive feature, is exactly what lets us tell pat from bat. It's the whole principle of phonemic contrast. One tiny change creates a whole new meaning. It's so simple, but so powerful. All right, next question. I want you to say kite. Now say gate. Feel that? Feel what's happening in the back of your throat. The sounds k and g are super close. But what is that one feature that splits them apart? Is it A, B, C, or D? You've got 5 seconds. Let's see that answer. If you said C, voiced, you got it. Take a look at this chart. For the k sound, that voiced feature has a minus sign. Your vocal folds are turned off. They're still. But for g, it's a plus. They're vibrating. That is literally the only difference. Everything else is identical. That tiny little buzz in your throat is what makes it a completely different sound. Okay, so we've seen how these tiny features make different sounds. Now let's kind of zoom out a bit with natural phonology, which is a theory all about how kids learn to actually use these sounds. They start out with these simple patterns, right? Like saying nana instead of banana. But as they grow, they stop doing that. So what's the official term for getting rid of these simplification patterns? 5 seconds? Got it? That word we're looking for is suppression. As kids' brains mature, they literally suppress these natural, simple patterns and start using the more complex adult system. Now, the big takeaway here is that phonological processes aren't bad. They're a totally normal part of development. It only becomes a disorder when a child doesn't suppress them around the age they're supposed to. You totally crushed round 1. So let's level up for round 2. Process power up. This is where we see how all this theory stuff connects to what you'll actually see and do in a clinical setting. Okay, here is a super classic clinical scenario for you. You have a kiddo and they say T when they're trying to say key, and Sue when they mean shoe. You see the pattern, right? What is the name of this phonological process? 5 seconds. Go. So what's the process? That is a textbook case of fronting. Just like it sounds, the spot where the sound is made, the place of articulation, moves forward in the mouth. So a sound that should be made in the back, like the K in key, gets shifted forward to the ridge behind your teeth to become a T in tea. This is probably one of the most common processes you're ever going to see. Now let's dig into a real case. This is some data from a child named Jonah, and it is a perfect example of a pretty severe phonological issue. Just look at this table. All of those different sounds on the left, K, G, S, Z, and so on, every single one of them is being replaced by just one sound, T. Just try to imagine how hard it would be to understand him. Ki, si, and she might all come out sounding like T. This points to a massive problem. Keep this in your head for the next question. All right, thinking about what we just saw with Jonah, where words that are totally different, like ki, si, and shoe, could all wind up sounding exactly the same? What do we call that? When all those different phonemes get smushed into one, completely wiping out the meaning. What's that term? 5 seconds. Let's see it. It's called a collapse of phonemic contrast. And this is a huge concept. It's not just about a kid saying a sound wrong. It's about them losing the very tool that we all use to tell words apart.
When those contrasts collapse, intelligibility just tanks because so many different words start sounding identical. This is a major, major red flag for a phonological disorder. All right, let's take a quick breather. You are 2 rounds down and you are absolutely killing it. We're about to head into the final round, the boss battle. This is where we really separate the contenders from the champions. So take a deep breath. Here we go. Welcome to the main event, Theory Takedown. These questions are really going to push you to think a little deeper about some of the more complex models in phonology. It is all on the line.
First up, let's talk feature geometry. Now, don't get intimidated by this diagram. The best way to think of it is like a family tree for sound features. You've got the main root at the top, and then everything else just branches off from there in a really logical, organized way. This model helps us actually see how different features are related to each other.
So, looking at this tree, where do all the features related to the place of articulation live? I'm talking about things like labial for your lips or coronal for the tip of your tongue. Which one of these major branches or nodes do they all fall under? Take a look. You've got 5 seconds. Which one's the parent node? It is the police node. See how all those specific spots, labial, coronal, and dorsal, they all branch off from that single point? This is really why feature geometry is such a cool model. Instead of just having a long, messy list of features, it shows us that certain error patterns, like fronting, aren't just random. They happen within a specific category, a single node, and that has huge implications for how we plan therapy. Okay, next up, optimality theory. I want you to think of speech development as a constant tug of war. On one side of the rope, you have what are called markedness constraints. These guys are pulling for everything to be simple and easy to say. Like dropping the S and stop to just say top. It's easier. But pulling on the other side are the faithfulness constraints, and they're demanding accuracy. They want the kid's version to be identical to the adult's. A child's speech develops as those faithfulness constraints start winning the tug of war more and more often. And that is it. You made it through all 3 rounds. You are officially a Research Rumble phonology champion. Seriously, give yourself a round of applause. But before you log off and celebrate, I have one final challenge for you. There's no timer, no multiple choice. It's just you and the concepts. So, chew on this puzzle for a bit. A child says guck for duck, but dumb for dumb. This pattern actually suggests the child knows something about the k sound in duck because they produce a sound with the same placement, that g. But they can't seem to produce that k sound at the end of a word. So why might that be happening? And, more importantly, if you believe they have this hidden knowledge, how does that completely change how you would approach therapy? That right there, that's the bridge from just knowing the theories to being a great clinician. Think it over and good luck on your midterms.